Hello, everyone. Thank you for joining today's webinar. My name is Alexis Batulis with Columbus, US, and today we have a special case study presentation for you on how you can consolidate data sources for enterprise analytics. We started the call by putting everyone on mute, so if you have any questions during today's presentation, please use the question box on the upper right-hand side of the screen to ask any questions that might come up during our webinar today. At the end, we'll have time for a Q&A with our presenter. Finally, we are recording the session and we'll be sending a link of the recording to all attendees within an hour after this webcast. Now I'm excited to introduce your presenter today, Mike Sims. Mike is the Practice Director for Data and Analytics here at Columbus. He's been in the data and analytics space for nearly 3 decades and has worked on data-specific initiatives on dozens of successful projects for companies in a multitude of industries. So without further ado, Mike, I'll hand it over to you.
Thank you, Alexis. As Alexis said, my name is Mike Sims. I'm the Practice Director for Data Analytics. I've been with Columbus for 16 or 17 years now, and I have been doing webinars and as well as in-person type of events for a number of years. I'd like to welcome you to this webinar, How You Can Consolidate Data Sources for Enterprise Analytics, a case study. Data and analytics is one of Columbus's core competencies, which include application managed service, Columbus and infrastructure services, cloud enterprise resource planning and strategy and change, as well as many other technology solutions. Our agenda today is going to start with our introduction. We're going to discuss the client background and then move into what we call the data journey, which is a key component in our analytics assessments. Next, we will move to the results of the assessment that we did for this client, which led to the pilot proposal that we delivered to the client. In that proposal, we designed the architecture and built the roadmap, which we are currently still engaging with the client on. Finally, I will demo part of the solution that we provided to the client and highlight the results and next steps of the engagement. We were introduced to this client in the spring of 2019. They are a fiberglass manufacturer with multiple plants currently in the United States. They were recently acquired and are now part of a multinational. The plants themselves were built in the mid-1900s and are essentially giant open furnaces that mix raw materials and allow it to flow from large batch silos through melters and finally into a bushing that creates the fiber strands. They're a medium-sized organization in the United States with several hundred employees. They were interested in reducing the reaction time to quality issues in the plant and decided to utilize Columbus to implement a solution using Azure technologies and advanced analytics. Their longer-term goal was to introduce machine learning to predict breaks. This client has a large amount of data from a variety of sources. They have IoT sensors throughout the manufacturing process, capturing thousands of different spots throughout the lines. Some of the types of readings include temperature, gas flow, oxygen flow, and pressure. The data capture frequency of these values varies from several readings per second to a filtered value hourly. Another significant source of data is at the end of the process known as the winder. This is the source of how the client was able to determine breaks and the rate of pull in the process. The data is stored by what is known as a position. Anytime a position is stopped or a bushing is changed, the data skews. Again, there was a significant amount of raw data available. Information is retained by shift, production line, break level, and product type, among others. In addition to these two main sources of data for production information, there were several data sources for material information that would be used for comparison. These data sources included gas, oxide, and property analysis in an Oracle database, certificate of analysis information in Excel spreadsheets, and a material tracking database that essentially captured all other data important to the client raw material information prior to arriving at the plant. Having data from all of these different data sources presented a significant challenge for the client. If they had a quality problem, it could take several weeks to identify and correct. This was a manual data collection process, and the analysis that was utilized was in Excel. Excel was used to create an analysis on a 7-day rolling basis, which is their normal way of analyzing the data. As a result of the time-consuming data collection and analysis, the production issue continued, and the quality levels of the product suffered. At Columbus, we have many tools that we can utilize to help us solve problems. One of the models that we utilize for data problems is a model we call the data journey. This model allows us to determine where the client is at on a spectrum of data and analytics. The model also helps us to explain to the clients the potential that they have within their organization, within their enterprise data assets. From the business insights to advanced analytics and data science and all points in between. As part of our analytics assessment, it is a key component that helps us to analyze the current state of the client data and analytics, determine the customer data strategy, and build the customer value proposition. The data journey guides us through the conversation with our clients. The way this chart is read is from the lower left to the upper right-hand corner. Each of the bullets is given a level number, starting with L1, progressing through L8. Most of the clients we engage with are in the lower left-hand corner, typically in the ad hoc reporting or query and drill down stage. The questions assigned to each of the bullets help to not only guide the conversation from the perspective of where the client is, but also helps the client understand that the progression from one level to another could take several steps. The bottom half of the chart represents what is normally thought of as business insights. Canned reporting and dashboards within applications, as well as black box solutions, are typically in this range out of the box. The top half of the chart allows us to move into advanced analytics and data science. Moving up into the L4 or L5 rather through L8 range requires some planning. The analytics assessment documents the information necessary and provides the plan to attain the goals for the client. It also allows us to identify the appropriate tools and services that best fit the client's objectives. You can see over here at the right that we have several very high-level services as a result of this data journey. Analysis and reporting, industry-specific analytics, corporate performance management, advanced analytics, business value consulting, and data management. Underneath each one of those very high-level blocks are several lower-level services that we can provide to help clients along this data journey. I'm not going to go into that today. That's a topic for a different time. But I did want you to understand that in addition to those services, we have a multitude of tools that we utilize, all from the Azure tool stack. The solution was to provide a consolidated view of the data that drove their production process and quality levels. Since they weren't comparing readings with production best practices over time, process improvements were not sustainable and in many cases weren't even achievable since the production had actually switched to a different product. The client realized that their data was stale and wanted a solution that would provide a more current, actionable information from their production process. The technology stack utilized for this solution was the Microsoft Azure platform. Columbus architected a solution using Data Factory for ingestion, Data Lake for storage, Databricks for manipulation, and Power BI for visual presentation. Utilizing these tools allows not only for reliability from a data ingestion and data manipulation standpoint, but also from the standpoint of a low-cost storage and visualization tool through Power BI. So how did we get them there? The first step was to have what we call, let me back up just 1 second here. The first step was to have an initial call with the client in order to determine at a high level the problem statement. After this call, the client agreed to an assessment in order to map out the details of the engagement. During the course of the assessment, we found out the following information. The client had embarked in a quality control efficiency plan for improving the process of manufacturing glass fiber in all of their sites. For this pilot, we focused only on one site and one furnace to ensure that we have control of multiple variables, as well as making sure that we can identify efficiencies and shorten the analysis and response time it takes to execute corrections once a problem occurs. The main challenge identified that causes deviation in the manufacturing process and causes quality problems is a filament break. This affects production and why this is the first challenge analyzed. Break level is the rate of fiber breaks at the bushing per hour of bushing running. That's known as BOBRH, breakouts per bushing run hour. This data is captured, and we have several years of history data available for analysis. The biggest driver for glass quality is throughput. Product mix is secondary. Other attributes to consider are temperature, glass level, glass oxides, glass properties, such as how glass transfers heat and quality. In other words, did we melt it very well? Since this one is very difficult to measure, we had to focus on the defects, specifically breaks. During the assessment, the areas of focus of our data analysis were in the following groupings: data-intensive areas, data sources, analytics, forecasting, key performance indicators, and other factors. One of the main takeaways of the assessment was the realization that this was a large problem that required many steps. As a result of this, it was decided to create a proof of concept project and to phase in other components of this project once the POC was successful. Since we were building a proof of concept, the two main areas of focus became the data-intensive areas and data sources. Analytics, forecasting, and KPIs would be handled downstream. Data-intensive areas focused on managerial decision-making. Some examples of this are historical furnace break level, as well as historical energy usage, HVAC usage, and raw material trends. The goal was process improvement. The goal was to attain 85% yield with a break level of less than 0.5%. The roadmap is utilized to visualize the data journey. It can be structured to provide milestones in order to gauge progress, but more importantly, it is utilized to help the client drive digital change in the organization by providing visibility to key points during the data journey and providing a time horizon to achieve them. It is similar to a project plan Gantt chart at a high level, but also allows for future phases to be added and removed as business priorities change. For this client, it was determined that they were in the L1, L2 region of the data journey. Their initial desire was to attain L3, L4. In order to achieve that, we recommended several activities. This roadmap is a sample of what we provided. The recommended activities were: implement the ODS framework using best practice Microsoft Advanced Analytics architecture, implement and utilize Azure Data Lake, ingest tables required for analysis using Data Factory, create appropriate schema to support analytics, and finally, create a Power BI workspace to showcase key reporting metrics that the client required in order to minimize quality issues. The proof of concept agreed upon would pull all of the necessary data required for the best practice report that they currently utilize internally into an operational data store in a data lake on Azure. From this data lake, all of the data required for the best practice report would be built into Power BI dashboard and a set of visualizations. In addition to automating this process and having all of this information consolidated into one place, this Power BI workspace would provide what-if capabilities that would allow the plant engineers to adjust the process variance in order to perform a comparison analysis with previous production runs, called pulls. Also, the Power BI workspace would have drill-through built in to analyze week-over-week comparisons for the best pull. This would help the engineers determine what process was out of control and how to adjust that process. In addition to supporting these subject matter areas and reports, the data warehouse framework for the ODS must support expansion for additional subject matter areas to be named later, as well as be able to support reports in existing models already built and deployed by the client. Finally, any transactional reporting needs within a traditional SSRS framework, with the exception of real-time or near real-time reports, needed to be supported within this DW ODS framework. The advanced analytics architecture provided the structure necessary for Columbus to build the POC. The data flow is as follows. First, ingest the data into your structured and unstructured, bring together all of your structured and unstructured data and semi-structured data using Azure Data Factory to Azure Blob Storage. Second, use Azure Databricks to clean and transform the structureless data sets and combine them with structured data from the operational databases or data warehouses. And third, use scalable machine learning, deep learning techniques to derive deeper insights. This was something that we had planned for in the subsequent phases, and in order to also showcase the Power BI reports and workspaces, we had to put this in at this point. As you can see here, there are two other components up at the top, Azure Synapse Analytics and Azure Analysis Services. We had proposed these as potential models for the data in subsequent phases, but those particular components are not enabled yet and haven't been put in as part of phase one. As a result, our model looks like this. This is the architecture that we use to structure the POC. Azure Synapse Analytics and Azure Analysis Services can be added on at a later time and will be in subsequent phases. So the proof of concept results were very, very positive. The results of these, due to the optimization of the production process by reducing the acquisition of data, led the client to feel that not only were they able to generate more revenue and increase uptime, but they will also be able to generate a higher quality product. In addition, at the extreme, they were cutting the response time from weeks to just a couple of days. Pause this for 1 second and go to the demo. Hang on one moment, I'm getting the demo, and here we go. All right, so this is a sample of the glass manufacturing analytics. This is not the exact same workspace that we provided to the client. It has been sanitized, and it doesn't have a number of features that we have since added. This is the February version of that deployment, and it gives us most of the information that we'll need to see for this demo. So this dashboard here shows us the break values here on a weekly basis, and it also shows our pull values, or BGP, on a weekly basis as well. You can see here we've got some other charts here. We've got Sunday to Sunday, week analysis, Monday to Monday, and so forth. These numbers here in the green represent the best breakage levels in the comparison sample that we're showing here. I'm going to show you these, although there's not any real good information in here because we don't have current data, but these are essentially control charts with upper and lower control bounds that we're using to run melter data for Sunday, Monday, Tuesday, and so forth throughout the week. And you can see these are just dots because we only have 1 point for them. So if I click into this one, it's going to take me into my best practice report from a Sunday perspective. And from here, we have some pull values and then some break values that we can toggle through here to do further analysis. When we want to do our weekly comparison report, the engineer will come into this particular screen and he will look at the variance up here. A higher variance means that we're pulling more information in to do a comparison with, and a lower constrains it more. And what we can very quickly see here is that this is our best pull break day and week in this particular data set. These tiles right here show us our breakage per hour and our current week pull with the variances that we've assigned to it, in this case 3%. If I right click and I go to the drill through, I have a current versus best week analysis. It takes a moment to pop up. There's an awful lot of data in here. Let's let it do its thing here. There we go. So you can see here we're comparing the 18th week and the 19th week, and we have global forming information, our calculations, we have some raw material targets that we're looking for, and we have some raw material composition. And then as we move down this screen, we're pulling in multiple different properties from our chemical labs and also energy profiles and properties around our plants and our melters in particular, and then different zones throughout the process that we can compare our numbers for. All of these numbers were being managed in one gigantic spreadsheet previously, and this is why it took so long for the engineers to actually compile and do the comparison of the data. There is an awful lot of information here. So what they would use this information for is if they found something that was out of range or suspect, or it was maybe going out of tolerance, then they would compare the numbers of all of these different processes and zones and parameters and so forth in order to determine, hey, how can we get this back on track? This allows them to do that much, much faster. The COA report provides information from the suppliers, and this has to do with excuse me, all of the different chemicals that are brought into the process. Now, one thing you'll notice here is that this slicer only goes up through February. Some of this data does not get updated very, very often because it's just the way that the suppliers are. They don't need to have most frequent data brought into this. This dashboard was actually just updated on Sunday, so that information must be the most current information that they currently have. And you can see here that we're looking at everything from limestone all the way through clay silicate down here, clay iron, and so forth. And they use this with their chemical engineers to determine, hey, am I out of tolerance? Is there a process? Is something going out of tolerance? And that's why you see these upper and lower control limits here. The LTM report is what's known as low temperature melting report, and they look at this report again to look at their break rate and their pull value and see where it is in comparison to their upper and lower control limits. In this case, we've actually added a warning level, which is this, I'm sorry, an upset level and a warning level. So you can see the different numbers that are brought into this control limit. So it's a more expansive, I think, control chart than what you would normally see with statistical process control. This toggle here allows us to look at data from a 7-day perspective or a 3-day perspective, and I think the 3-day, yeah, 3 days rather boring because we only have 2 days of data. But you can see here the 30-day worth. We could change this toggle to be 60 days, 90 days very, very easily. But this is the kind of information that they wanted to see because they wanted to be able to react within 3 to 7 days. The historian information provides, trying to close this, not letting me. There we go. Provides gas and boost data, and it also provides mug data. Mug data is what is known, mug data is what is known as canals within the process, and the canals are monitored for temperature variances because as the glass is moving down these large channels and these large production lines, the temperature can vary a little bit, and in some cases a lot, and they want to try to maintain that. You can see here also that they're looking at their gas and boost total by date in order to determine what kind of energy utilization that they're pumping into the system. These QPAS charts are basically looking at the chemical composition of the gas that's going in, and there's some calculations in here, and you can see they have things like bubbler flow, and they have hotspot initiations here so that they can monitor these particular processes. We also have this slider here so that they can hone in if they had a specific time that they thought was more efficient than another time. Now these last several charts here are pretty much all the same. They were done with R, and they'll take pretty fast actually. And the reason that we did these in R is because they wanted multiple vertical axes. So on this axis here, you see we have a hotspot, we have I'm sorry, we have a set point, we have a hotspot, we have the pull rate, and we have the break rate here. So you can see that they can monitor pretty easily by looking at that, all four of these imposed on each other. I change this, that gives me a little bit more finite. It comes back. Oh, it already did. There we go. So this one right here, I think adds two more variables to the vertical axis, TMA and TCA, in addition to the four that we already saw. And then this one is a slightly different chart that looks at chrome, zircon, sulfates, and hotspot for comparisons. Okay. So let me move on to the next. So the next steps are, since this POC had gone pretty well in the client's eyes, they wanted to add all of the remaining production lines into the data lake and build the ingestion for all of those production lines and plants that they have remaining in their organization. In addition, they want to utilize machine learning to try to predict the breaks. Now that we have all of this data combined in one spot, they want to really dig in and determine, hey, what are the key factors in order to try to predict these breaks so that we can be more proactive instead of reactive. In addition to these main drivers, the client wants to build out the remaining data intensive areas that were not addressed in the POC. Remember I said that they had like 6 main data areas that they wanted to focus on, and we really only took 2 of them and built the POC around that. Specifically, they want to add event capture for quality corrections during the production process. So any decision event that would be tracked in order to monitor the positive or negative impact and effect on the system regarding the breakage levels would be monitored within the data lake and then produced as a result in the workspace. Another key area is to allow for more what if and parameter-driven tolerance analysis. Specifically, they want to open up the tolerances so that they can bring more of their glass pools in for analysis purposes in order to see if there might be some hidden gems in there. And this would also allow their engineers to look at more information from production runs across lines and plants. A key area of the assessment that was put off until the POC was completed was in the area of analytics. There are a number of company-specific and industry-specific key performance indicators that need to be finalized and in many cases defined and developed. This is another initiative this client wants to pursue in the next phase. In addition to machine learning models for breaks, this client wants to pursue several machine learning models, including predictive maintenance and inventory forecasting. Some of these lines are 60 and 70 years old, so maintaining them is paramount. They're very, very large and fairly easy machines, but they do have a lot of very, very hot parts. So being able to predict breaks or shutdowns is something that they would like to do. Finally, the client wishes to expand on the Power BI Workspace by adding all of the additional production lines as well as additional slicers and visuals in order to drive their business. So a recap of the results. There was optimized production with less waste and improved product quality overall and reduced breakage. Significantly easier consumption of information with customized Power BI dashboards featuring trends and control diagrams. The ability to access and analyze data much earlier in the process. We're talking days as opposed to weeks. And the desire to move on to subsequent phases. All right, Ali, I think we can open it up for questions if there are any.
All right, let me see here. I don't see any questions entered in yet, so if you guys have any questions, please be sure to enter them in now. I'll give us about a minute here. All right, great. So it looks like if we have no questions, I would like to thank you all for attending today's presentation. We do have a brand new workshop coming up next week called Dashboard in a Day. This is a free 5-hour workshop that'll cover the full capabilities of Power BI. You can register for this and check out our other virtual offerings by clicking over to the Events tab located on our US site. Just go to columbusglobal.com. We'll also be sending out the link to register for this event in the follow-up email you'll get in about an hour after our broadcast today. Again, if you have any additional questions that come up, please reach out to us at our contact email, us-marketing@columbusglobal.com. Thank you so much, Mike, for giving us a great overview of this enterprise analytics case study. That concludes our webinar today. Thanks again, everyone. Have a great rest of your day.